Hey guys, welcome back to the channel. So let's do the next problem on the list. It's a medium level problem and seems like it will be tough because it got a hint and hints will be given for tougher problems. Let's say deepest leaves some given the root of a binary tree. Okay, root, right? Return the sum of values of its deepest leaves. And what are deepest leaves? 7 and 8. The number of nodes in the tree is in the range 1 and n to the power of 4, and 1 is less than or equals to node value, and okay, node value is in between 1 and 100. So let's see the test cases again, and here the deepest nodes will be 5, 9, 1 and 4, I guess. 9, 1, 10, 5 plus 4, 9, 19. Well, let's add a case and see what will be the answer. If we remove 9 and 5 here, I guess we'll have 5 as answer. Well, let's see. Let's keep off so that we won't get an error. One thing for sure, let's see how we can do this. The deepest. Well, it feels like let's see that BFS kind of problem. So what if we remove five and then 6? Now I guess the answer should be 6. Okay, so let's go do the BFS, for which we have to create a queue. We don't need to add edge case because we sure will have one value at least. Now we created a queue, so we need to traverse here. So we keep a loop to traverse, and we'll have one node at first, which will be the root node, for which we have to do length of, let's take the length of u as a static value for one loop, and let's keep length equals to 12. No, Let's loop through the queue until L. I mean the length L. Now we have to pop one item at a time. We can pop from the left or pop from the right. So let's pop from left and add elements to the right so that we'll get a value of a list at a time. And let's keep it temp. I mean value of a level at a time. Wait a minute. Let's keep temp outside or inside temp. Okay. Keep them both outside and inside. This is not included, so let's keep it here instead. Now it is good, so we'll go through each item in the list, and no one should be from queue. We are copying elements from the left, that is starting from the starting index. So dot append the last dot left. And same goes for the right. Let's copy this and paste it here. Now let's increment the temp. And let's return it here. Let's try running it again. Well, seems like it is working fine, but I think it can be even more optimized. But whatever, let's try this first and then see what other solutions we have. It seems like it is one optimal solution and it is not taking much space either, because the range is not very big, like the difference is not very big. So let's see the topics. DFS, BFS, vendor review. I don't know how we can do it in BFS, but it's better to know how to do it in the BFS. Traverse the tree to find the maximum depth. Traverse the tree again to compute the sum requirement. Traverse the tree again. Well, in the DFS, I guess we have to pass the level. Traverse the tree again to compute the sum requirement. Oh, so the DFS, well, we have to find the deepest level and we have to add values from that level to the value, I guess, which will be helpful in the DFS. Let's see how others did for the same problem. Well, some did the iterative approach, which is BFS, breadth first search, breadth or whatever it is. I couldn't see a DFS approach, but I sure can expose traversing the return sum plus maximum depth. Great. So the maximum depth is 0. It's not root dot left and root dot right. Return. Okay. At the leaf node it is returning 1, and else we are going to go left and right here. If a of 1 equals to b of 1, if both are on the same level, you are returning a of 0 plus b of 0, 1 plus a of 1, which is increasing the depth. And well, if a of 1 is greater than b of 1, into a of 0, well, this guy made it more complex, but it sounds intuitive. Well, he's kind of doing the backtracking. So by the time he reaches the leaf, he's returning 1 and that root value. And when it returns, if a and b are on the same level, we are adding both a and b and increasing the level by 1. If we have both of them on a different level, then we are taking the maximum level and incrementing the level again. And doing a of 0 instead of adding things. So I hope you guys understood the intuition. Like, did I explain it? It is very self-explanatory. It is PFS, where we have added a value to the cube and maintaining a temporary variable. Why did I declare it inside and outside? That is because if I have implemented it inside, and let's see if it gives any error, or else it should be right. Well, I just thought it will cause a, what do we call it, temp value is not declared kind of error, but it handled pretty good there. So well, we have implemented a temp here, declared a temp, and we took the length of the variable first hand, length of the queue first hand, and we are traversing through that length and adding, like, while traversing we are removing elements from the front, which will remove all elements from the previous level, and adding values to the end which are of the current level, which will be traversed again in the next level by taking the length. And by the time we reach the end, which is the final level, we will get the sum of all the values from that level, and we are returning it. I hope you guys understood the intuition. If you like the video, upload it and share it with your friends, and subscribe to the channel. Thank you for choosing the channel. We'll meet you again with another video. Until then, keep learning and keep pushing hard. Goodbye, guys.